This video will cover how to install and run Tapestry using Docker. All commands shown will be run and tested from a Microsoft Surface Pro. First, we must use Docker to download the pre-built Tapestry image from Docker Hub, which includes one dataset. After, we can run Tapestry interactively from Docker using a single process. For this, we must publish a port from inside the container to the host. Here we have chosen port 8080. We then open the browser to our Tapestry instance and specify the included dataset. Images come back sequentially because we are only running one server, but this will be addressed later in the video. Now we look at how to use your own data with Tapestry. To do this, we need two directories, config and data. The config directory will have as many JSON files as you have datasets. In the configs, we must specify the path to the data volume and any rendering parameters. We only need to tell Docker to use the new directories instead of the ones provided. Now we open the browser and change which dataset to show and see that our data has loaded. Next, we will look at how to modify the web page that Tapestry sends, and thus change the front end of the service. This is done by modifying the service's app directory and the index.html page inside. First, we show the default page that we will later change. We again need to tell Docker to use our app directory instead of the provided one. We now kill the service and modify the files. In our example, we change the quality of the hyperimage, though any change is possible. When we rerun the service, the new files are in place and we can see the changes in the browser. Next, we showcase how to run multiple instances of Tapestry as a Docker service for improved performance. Before we begin, we need to create a Docker swarm. Here we are only using a single node, but if you have many nodes, you will run the join command on each one. Instead of Docker run, we now use Docker service create. This allows Docker to manage the number of instances and has a built-in load balancer so any instance can respond to rendering requests. If we are not getting the desired performance, we can later scale up the number of instances. Now rendering is spread across all three services and happens in parallel. Finally, we show how to use your own data with multiple instances. We must specify our data and config directories differently because we are using Docker service create instead of Docker run. Again, we must tell the front end to use our new dataset. For improved performance, we can use Docker to scale our service.